Okay, so we're going to have a look at another advanced mechanics question. So this one is just asking us to find the initial velocity components for the following examples. So we'll do these separately. We'll start with example A. So in example A, we're told the launching angle is 65 degrees up and the speed, the launching velocity, is 45 meters a second. So let's draw a diagram of this. So the launch angle is 65 degrees, so this is 65 degrees. And the velocity, initial velocity, is 45 meters per second. So we need to find the x and we need to find the y. So the x will be the one going across this way. The y will be the one going up this way. So this is y, this is x. So to find the x, velocity in x, we'll use cosine. Cosine 65 is equal to velocity in x over 45. This implies velocity in x is 45 times cosine 65. Now we just want decimal approximations for these because this is just introductory physics. Cosine 65, and we like decimal approximations. So this is 19.02 to 2 decimal places, and this is meters per second. And then we want the velocity in y. So this one we'll use sine. We have sine of 65 is equal to the velocity in y over 45. This implies velocity in y is 45 times sine of 65. And again, we're just going to decimal approximate this. So we get 45 times sine 65 gives us 40.78. 40.78 meters per second. And they're both positive. This is velocity of x is going in the positive x direction, velocity of y is going in the positive y direction. And these are the answers for part A. Now, for part B, we have a slightly different example. We're told 25 degrees down at 50 meters a second. So now we need to draw a slightly different diagram. We need to draw a diagram that looks like this. Starting here, 25 degrees down. So that means the angle is 25 here. Remember, this is still positive x, this is still positive y. That means down this way is negative y. So whatever our answers are, we will still have an initial velocity in x that's positive, but now our initial velocity in y will be negative. So this is 50. So we need this vector and we need this vector. This is initial velocity in x, this is initial velocity in y. So we're going to use cosine to find velocity in x. Cosine of 25 is equal to v of x over 50. This means v of x is 50 times cosine 25. 50 times cosine 25 is 45.32. 45.32. That's 2 decimal places. That's meters per second. So that's the velocity in x. Then we're going to use sine to find velocity in y. We have sine of 25 is equal to velocity in y over 50. This implies that velocity in y is 50 times sine of 25. 50 times sine 25. 21.13. 2 decimal places. And that's meters per second. Now, we're not finished because this velocity in y, 21.13, is actually not correct. This needs to be made negative. So actually the real velocity in y here is negative 21.13 meters per second because it's going down and not up. Right? So the method we used for both of these questions was exactly the same. We just drew our little triangle and then we used basic trigonometry to work out what Vx and Vy were. But if you have a initial velocity vector where one or both of the components is and or are in the negative directions in the plane, you should specify that, right? So you should say 25 degrees down at 50 meters a second has a velocity in x of 45.32 meters per second positive and 21.13 meters per second negative. So this is something that you should specify in the question. when you are writing your answer.